Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 7, Chemical Foundations, Part 7. This is the last video in Chapter 1 of your textbook. Here are our objectives for today's video. Pause here. It is up to you if you want to draw this picture. So you have all obviously seen this before. It's probably pretty straightforward to you. You're probably fully aware of which ones have definite shape, which have definite volume. You're fully aware of the transitions, the fact that all the transitions, this transition from solid to liquid, liquid to gas, and solid to gas, those are all endothermic. The transition from gas to liquid, liquid to solid, and gas to solid are all exothermic. So that should all be a little bit of a review for you. But all of this has pretty profound impacts on behaviors of things. We're going to do a whole chapter just on gases. We're going to do a whole chapter just on liquids and solids towards the end of the year. So all this stuff really does have meaning, and you do need to really understand it well in order to predict some behaviors. Pause here. So I'm just going to say the answer out loud. So melting, that is an endothermic process. You have to add heat to make that happen. Subliming, if you didn't already know what that was, that is the transition directly from solid to a gas. So you might see that, let's say if you have dry ice, and that is an endothermic process. And then condensing, the transition from the gas phase to the liquid phase, is an exothermic process. Pause here. So there are two basic types of substances that you will see in labs, and the way that we treat them will be different. So a pure substance consists of one type of atom or one type of molecule, so those can be elements or compounds. With pure substances, when you are in a lab, you will always be doing typically some kind of synthesis or some sort of chemical reaction. Whereas mixtures, we're going to treat them differently. Mixtures are physical combinations of two or more elements or compounds. And then we're typically going to be doing either like an extraction, or we're going to be doing some sort of separation. And both of those processes are fundamentally different from a chemical reaction. Then there are two types of mixtures. The first type is a homogeneous mixture. So these are things that are uniform throughout. So this would be, let's say, like gasoline. This could be salt water, where the salt is completely dissolved. And if you want to separate those type of mixtures, you're going to need to use distillation. So that's when you boil a substance and separate the different components by their boiling points. Or chromatography. Chromatography doesn't really get you at the end what you started with. It more just gives you information about what was in your mixture. We're going to be doing some experiments with that. So if it's still not clear what chromatography is, we will do an experiment so you can see that. Heterogeneous mixtures are not uniform throughout, and so we can separate them just with a filter. So typically one component will be, let's say, in a liquid phase, and one will be in a solid phase. So anything like that would be a heterogeneous mixture. So that would be like salad dressing, pretty much anything from a plant or animal for the most part will be heterogeneous, so on and so forth. Pause here. So then there's different types of changes, all of which again have different ways that we use them in a lab. So physical changes are changes in state. So you can reverse a physical change by changing temperature and or pressure. So all of the things I described for our mixtures were all sort of physical changes that we use to separate a mixture. Whereas a chemical change, those are a change in composition. Those you cannot change just with temperature or pressure alone, unless for some reason that causes a chemical reaction. That's extremely unlikely though. So without doing a second chemical reaction, you cannot reverse a chemical change. So like burning, rusting, etc. Pause here. All right, I'm going to work through this with you. And as we work through it, I'll give you like just a sort of general guidelines. So generally speaking, anything from a plant or animal, and the vast majority of foods, will be heterogeneous. And then there's some more obvious ones. Homogeneous, so that would be a solution. So that would be if one component is completely dissolved in another. And then for, I'm also going to add alloys here. You've probably heard of those before. Those are just homogeneous mixtures of metals. And then we also have pure substances. These will typically have, let's say, a chemical name or the word pure in front of them. So you would have something like carbon dioxide. So it wouldn't be like air, it would be a more specific name. So those are just things that are generally true. They're not 100% always going to be the case, but it's a pretty useful guideline. This is the guideline I use when I make, let's say, tests for this class, unless I've specifically told you examples that deviate from this, but I wouldn't just pick an example you hadn't seen before that deviated from this. So the first one is heterogeneous, because that is a food product. If you were to place a filter underneath orange juice, you would see sort of orange gunk on the filter. This is a homogeneous mixture. So that is, I would need to use distillation for it. See, this is heterogeneous. I know that it says homogenized on the label. That doesn't mean that it is actually homogeneous. It's a food product. It's actually called a suspension, things like milk or even like clear juices, where there are still, there are very tiny particles that are solid that are mixed throughout, but you can't really see them. Pure water, as the name would indicate, is pure. Then we have tap water. This should be a homogeneous mixture. There are dissolved gases in there, hence why we have like the pH of water that you get from a tap is actually not 7 because of the dissolved gases in there, hence why fish are able to breathe because of the dissolved oxygen in there. And then salad dressing, again, this is a food product, so this is heterogeneous. That is all for tonight. Thank you so much for watching and have a great night.